Okay, so now let's work on some example problems that people had questions about. So I'll start with the one that the most people had the most question about, and this is example 13-6. This is a series RL circuit, has a resistance of 1 kilo ohm and inductance of 1 millihenry. What is the time constant? So just like a capacitor stores charge and an inductor stores charge. So just like you get that exponential behavior with a capacitor, you get that exponential behavior with an inductor. Okay, so the time constant for an inductor is given by tau equals inductance over resistance. So in this case, the inductance L is 1 millihenry, which is 1 times 10 to negative 3 henries. Okay, and the resistance is 1 kilo ohm, 1 times 10 to the 3 ohms. All right, so I put these in, and 1 times 10 to the negative 3 henries divided by 1 times 10 to the 3rd ohms, okay, is, now interestingly enough, this works out for units of seconds. I'll try to explain. How these units work out for these time constants. But for the moment, I'll just work this through. Okay, so obviously 1 is just 1, and then 1 over 10 to the 3 is 10 to the negative 3. So that's 1 times 10 to the negative 3 times 10 to the negative 3, which is 1 times 10 to the negative 6 seconds, which is 1 microsecond. So then it says find the time constant for 2.2 kilo ohms and 500 microhenries. All right, so tau equals L over R. L is 500 microhenries. R is 2.2 kilo ohms. So this is 500 times 10 to the negative 6th divided by 2.2 times 10 to the 3rd. So that's going to be 500 over 2.2 times 10 to the negative 6 times 10 to the negative 3rd. So that's 500 over 2.2 times 10 to the negative 9th. So now I just need to do 500 divided by 2.2. Go to calculator over here. Calculator. 500 divided by 2.2. And I get 227.3 times 10 to the negative 9th seconds. So that is 227.3 nanoseconds. So that is our answer for this problem. Right. I hope that I've tried to adjust this screen, but I get these reflections of the lamps in the room. This isn't in our usual classroom, and the boards are a little too shiny. All right, so I'll check and make sure that answer is correct off the back of the book. And yup, this is the correct answer. Okay, so this is the one that the most people had questions about. Let me erase this off. I'm trying to explain this business about why the time is the way it is. Because the math isn't that hard on this. So I'm guessing that's kind of where people's questions are. Okay, so still talking about example 13.6. I've erased the board. Now, the equation for time constant is L over R, inductance over resistance, Henry over ohms. Why does this turn out to be seconds? Well, if I come over here, I look at the equation for inductance. voltage equals inductance times change in current over time. So volts equals henries times amps over seconds. Ohm's law is current times resistance. So volts equals amps times ohms. So an ohm, if I divide both sides here by amps, then an ohm is a volt divided by an amp. If I come over here and then divide both sides here by an amp per second, that cancels out. This side is an amp per second. Then I get a henry is a volt over an amp per second. So I'll put this in here. A henry is a volt divided by an amp per second. An ohm is a volt per amp. There. So the volts cancel out, the amps cancel out, and what I'm left with is 1 over seconds, which is seconds. So that is how the time constant yields seconds in these example problems. That's why this comes out in seconds. Same thing works with capacitor time constant. The time constant is R times C. A capacitor, so R is a volt per amp. Capacitor is farads is what is it? Joules per, no, not joules per coulomb. Well, I can't remember off the top of my head, but the units will cancel out. I don't think I want to go back and work on that because I'll get us back confused with farads. I don't think I can do that in my head. I have to have it on the board. All right, I'll go to the next question. Okay, so now let's look at, this is another question several people asked about, was example 3.2. Determine the inductance of a coil in figure 13.5. 13.5, coil. All right, so it gives the length of the coil is 1.5 centimeters. The thickness of the coil is 0.5 centimeter. It's 350 turns in the coil. So the length, 1.5 centimeters. The diameter was 0.5 centimeter. And the number of turns in the coil is 350. Now, the inductance formula is L equals number of turns squared times mu times the area divided by the length. All right, so first thing I'm going to do is turn these all into metric meter units. So this is 0.015 meters. This is 0.005 meters. So I got the N, I got the L already, the little l. The area is what I need to find. So the area of a circle is equal to pi r squared. So that's the diameter. So the radius is 0.0025 meters. So that's pi times 0.0025 meters squared. So I'm going to put that in, take this, and put it in for the area in this formula. So now L is going to be equal to 350 squared. That's n squared, 350 squared. Mu is 0.25 times 10 to the -3 henries per meter. Area is pi times 0.0025 meters squared, all divided by 0.015 meters. Needless to say, this is the kind of thing that it's easy to put into a calculator and goof it up, okay? Because there's a lot of stuff here. So I'm going to try to break it down into pieces. So I got 350 squared. That's 500. Then I got 0.025, whoops, 0.25 times 10 to the -3rd. Then I got pi. Then I got 0.0025 squared, 0.0025 squared. So that's 0.000000625. And then all that is over 0.015. Okay, this one is, let's see, 1, 2, 3, 4, 5, 6. So that's 6.25 times 10 to the -6. 1, 2, 3, 4, 5, 6. Okay, so -3 and -6 will be -9. So this is going to be 122,500 times 0.25 times pi times 6.25 times 10 to the -9, all divided by 0.015. So I'm going to multiply this times this times this times this divided by this, and it'll be times 10 to the -9 over there. So try it out. Hope I don't screw it up. 122,500 times 0.25 times, where's pi on this calculator? Pi times 6.25 equals divided by 0.015. Good boy. So I got 40,088,031 times 10 to the -9. That's 1, 2, 3, 4, 5, 6 there. So that'd be 40. I'll just say 40 times 10 to the 6 times 10 to the -9. So that's 40 times 10 to the -3. I've added a 1 in there. Okay, because 10 to 6 and 10 to -9, they add up. So I get 10 to -3. So 40 millihenries. 40 millihenries. Ah! I got the right answer. Okay, good. All right, that's a math. That's pain. Okay, that one's a pain. All right. My recording's getting too long here. Let me stop it. I'll do the rest.